This video is a continuation to the previous video. So this video now is more about converting DXF of the type points. So the geometry type is point, and the container is a DXF file. So we want to show you how you can convert that to geo. So one thing you have to mention here to you that DXF is not the best format to handle points or to model points. So points, like we're talking about something like this. It's a grid. So you've got point here, point here, point here. So they are sampling the terrain using points, something like this. So if you have points like this or a grid, you better use the TIFF format, GeoTIFF, not DXF. But anyway, so we have clients who sharing with us points dataset terrain, topo map in a DXF container or DXF format. So we're going to show you how you can convert this into a digital terrain model. So the process is normally is something like this. Let me summarize the process a little bit. So we're going to convert the DXF. So here we're talking about points this time. So we convert the DXF into Esri shape, and then we're going to use the shape to create a blank matrix, and then we're going to import these points from Esri shape file into a terrain, and then we may or may not do interpolation. Now I'm saying that because they're using points, that means somebody already have done the interpolations. Somebody have already the data in a grid. So if you already have the data in a grid and you've got plenty of data in that grid, then every pixel will have a value. But if the points are separated by massive distance, okay, and then you wanted to put it in a smaller grid like this, then obviously you're gonna end up having many pixels with no values, and in that case they need to be interpolated. So let's see. I mean, normally the source would describe for you a little bit more about the grid size. So I think the grid size in that case is a 2x2. It's a 2x2, so which means you can put it in 2 meter resolution. Okay, so I'll probably go with the 5 meter resolution, but yeah, the source is 2 meter resolution. So let's proceed to step number 1. You want to convert. To convert, you need to go to map and then use the built-in map data converter in HTZ. And you can use this option here, batch vector converter. So we're going to use the converter, navigate first to select the DXF file, the source DXF, which is this one here, points, and then I don't want to do all the folders, just want to do this specific DXF file. The destination will be the same location, destination. And you need to check the option here, point as a geometry. And as we said with the previous tutorial, the DXF doesn't accommodate the EPSG or the coordinate system. There's no header information there that we can import. So I'm going to leave it 0 and hit OK. So the software now will make use of the GDAL libraries to translate DXF into Esri shapefile. Now, if you want to do that step using your own GIS software, QGIS or MapInfo, ArcGIS, you could actually, okay? So you could convert from DXF to shapefile. If you have, if you can ask your provider to give you the data in shape format, then you could save time. You don't have to do that step. So looking at this here, the files are being produced. It's not finished, obviously. The source that I'm using is almost a gig, so it's 975 meg. So the process can take some time. Conversion is completed. Now notice the file is more than 1 gig, the shape file produced. So obviously DXF is more efficient than Esri shape. So press enter here to close the interface. So it's done. The shape file is here. Now, next step is I want to create a blank matrix so I can import these points. So normally you could do this with the under file outdoor project from shapefile. We've used that feature before to convert contours all the way to a project and digital terrain model. So it was very quick and easy. But I think this one doesn't support contours. We can try see if it supports contours. But yeah, if it supports contours, you would be using it would support points as well. You would use the import shape as elevation. Otherwise you can still go the blank metric. So I'm gonna try now, just see if I can use this feature here to go straight all the way to a project. So step number one, you need to use that point source that you have. So I'm assuming that the coordinate system is MGA55. You really need to know what the coordinate system is. You cannot keep it blank. It will give you lots of problems. So you need to know from the source what is the coordinate system is. And you can use ATDI built-in coordinates converter to find the equivalent coordinate system. So I'm going to assume for now that you are comfortable with the ATDI coordinate codes conventions. So this is the output. So the output will going to be saved. I think the tool is still scanning the contents. Okay, so select the PRO file. So I'm going to call this, I'm going to use the same name as this one. That's the PRO, save it there. The coordinate system I'm going to use, the project step I'm going to use is 5 meter. Most of the time for mining, 5 meters is sufficient. MGA55, just like the input. And the import shape Z as elevation. So we also spoke about this in the previous video. So we said because the elevation information are not explicitly defined as attributes, it's embedded in the object or the geometry itself. So that's why you have to check that box. So I'm going to try this option for now. If it doesn't work, then we have to use the blank metrics approach. Okay, so this technique didn't work. So what I'll do, I have to fall back to my original plan, which is creating blank matrix and then importing the shape files using the tool instead of doing the whole thing in a automated fashion. So I'm going to go back to file, I'll do a project from shapefile. I'm not going to save this terrain, obviously. Now you're just exploring the file contents. Alright, it's done. So this is the point, MGA55. And here I'm going to use a create DTM blank matrix instead of going straight to DTM. So hit OK to go and create the blank matrix. This is the blank matrix. Effectively, it is done. So now what I'm going to do, I'm going to go file and map, and then go to raster operations and modify DTM from points. So it's not polyline because these are not contours, they're not mesh. So I'm going to go use a point and then browse, and these are the points. So MGA, we said MGA 55 is the assumption here, and column with elevation is none. So because this is it's an object, it's a point Z object, so the elevation is embedded. So, see point Z, if it's a point Z object geometry type, you have to use -1. Otherwise, if it is explicitly defined in the attributes of the shapefile, then you can use this arrow to map it. So -1 and hit OK. So here you go, we see it working now. It's pretty quick actually. So this technique is working smoothly, but it's just more involving. This requires creating the blank matrix first, and then importing, and then finally interpolation. Now, lucky because this this source, DXF source, is originally is made of points, and there's so many points in that DXF file. So it is possible that we don't have to do interpolation at all. So what I'm trying to say, every point in the DXF is falling in a pixel, in one pixel. So it's kind of one-to-one mapping. So you won't have gaps. You wouldn't have gaps in that case. Which, if there's no gaps, then there's no need for interpolation. So it's done. So you see, this is the digital terrain model, and I don't see any gaps. If there's gaps, it would show up as probably something like this. So this is elevation is what 0. There's no 0. 225. Oh, they look good. These ones, they look okay. So this is here is a gap or 0. Obviously, there's no data here, so void. And here you actually have data. So it looks all good here. If you find there's gaps and you want to get rid of, you need to interpolate. So you could use the functionality here on the map, raster operations, and then you'll find here DTM interpolation. So you can use the LIDWI interpolation, which is 1 here, and then you can run the interpolation. So it will go through the void pixels and then try to interpolate. Now obviously there's no void here, so there's nothing to interpolate, but maybe outside it might try to extend it. Now I don't want to over interpolate things, so I can escape to stop it. So if you're not seeing any changes happening here, there's no point you run interpolation to stop it. Otherwise you start to over interpolate things at the edge, which you don't want that. So this is done now. Control S, and that will save the dim for you if you haven't saved it. And yeah, this is the process for converting a DXF point into a geo file supporting HTZ format. So if you have any inquiries, feel free to reach our support team, and we'll be more than happy to assist you. Thank you.